Good afternoon, everyone, and welcome to the third session of Science in Progress. In Science in Progress, we take you through a journey of the latest scientific research in the UAE every Monday and Wednesday with my colleague Amal and I. Before we start, if you have any questions, please post them in the Q&A tab. Our guest today is Mariam AlShamsi. Mariam is the director of the Space Science Department in the Mohammed bin Rashid Space Center. She's a member of the Emirates Scientist Council and she heads the Youth Science Council. Mariam is going to tell us today about the space sector in the UAE, a hot topic these days because of with the recent launch of HOPRO. Mariam, it's good to have you here.
Thank you, Amna. Assalamu alaikum. It's good to be here and thank you for inviting me in this series.
Mariam, let's start with this. Can you give us an overview of the space sector in the UAE?
Sure, Amna, if you can allow me, I'm going to be sharing slides. Just a moment. So just let me know if you see the slides.
Yes, we can.
Okay. Assalamu alaikum and good afternoon, everyone. So I'm going to be presenting to you about what kind of research is being done in the UAE in terms of the space sector and the different projects we have. Just a moment. Okay, so as you see this picture, I think if most of you, if not all of you, have seen this picture posted a couple of months ago or even weeks ago. And this picture basically is from 1976. And as you can see, His Highness Sheikh Zayed bin Sultan Al Nahyan, peace be upon him, meeting with a group of astronauts from the moon, Apollo moon landing mission. And the image basically signifies the start of the space sector here in the UAE, and also it sparked an interest in the UAE to go into the field of astronomy and space sciences. And not only that, also onwards from that time, a lot of governmental and public entities have gone into developing space-related satellite development, basically, in the UAE. And as you can see from this picture here, the UAE focused on maintaining and also developing satellite programs. So starting with Thuraya, that began or was established back in 1997, and we have communication satellites and Eliasat as well, developing satellites for communication uses in the UAE. We also focus in the UAE in terms of remote sensing satellites. So we have a couple of satellites that I'm going to be discussing today. We have DubaiSat-1, DubaiSat-2, KhalifaSat, and also when it comes to education-related missions, we have NAIF-1, which was launched in 2017. It was developed by a group of students from the universities. So the basic the purpose of the project was to develop capabilities also when it comes to university students, developing different subsystems of a satellite and understanding how satellites work, and in terms of even the processes in terms of the project itself. We have DMSat as well, which is also a scientific satellite. I'm going to be talking in a bit. And when it comes to outer space related projects, we have HOPRO, as Amna mentioned, actually launched last week successfully, studying the purpose of it will be to study the atmosphere of Mars. And I'm going to be talking about that also in a bit. Now, when it comes to the National Space Program in the United Arab Emirates, we have 4 pillars of focus that aligns with that. We have the Emirates Mars mission, which I'm going to be talking in a bit. By the end of this presentation, it's sending a probe to study the atmosphere of Mars. We have the Satellite Development Program, so there's a lot of projects underneath this umbrella. The Mars 2117 strategy, and the UAE Human Spaceflight Program. So when it comes to Earth observation satellites and remote sensing satellites, it all started with development of DubaiSat-1, which was a knowledge transfer and collaboration between two entities, Mohammed bin Rashid Space Center and SATRC initiative in South Korea. Along the years also, we developed Dubai Sat 2, also collaboration between both of these entities. And then Khalifa Sat that was successfully launched 2 years ago with a better resolution. So as you can see, we are developing our in-house capabilities through these projects. We're adding our expertise when it comes to Earth observation satellites, but at the same time, we are advancing in terms of technological aspects of the payload and the resolution of the imagery that comes in. So what can you do with these satellites? So the most important thing is to know exactly what you're trying to study. And from that, you need to know what kind of spectral bands or scientific data that you would require to, for example, answer your science questions or demonstrate a theory, for example. So a good example is Khalifa Sat. So Khalifa Sat, there is a lot of scientific research that can be done with the images. So Khalifa Sat has the RGB band, but also near IR spectral ranges. So you can do urban application for a specific location, for example, and monitoring how it changes with time. If you want to see in terms of an infrastructure of that area, if you want to, for example, build something in that area, is it accessible? So we have a lot of local entities approach us in order to know about monitoring a project, for example, and seeing how the development is going in time. Also, we can utilize these imagery in terms of environmental applications. So you can see how, for example, the health of the vegetation. Is it healthy? Does it require more, for example, maintaining? How many trees are there? So a lot of environmental application can be utilized with these imagery to do also further studies. Object and feature detection. So you can monitor an object with in terms of time and see how the feature changes with time in terms of geology of that area. Site exploration and 3D mapping. So a lot of application that can be used also to see, for example, the height of the mountains. For example, Burj Khalifa, you would like to know how tall it is, or if there is any specific changes in time in terms of a specific geological area. Also in terms of disaster management. So if there is, for example, a flood in a specific area and you would like to see the changes that happened from that flood and how catastrophic, for example, it was on a specific location, this also can be done. And it also can feed into answering science questions and understanding Earth more in terms of these different areas. So there's a lot of applications not limited to these that also can be utilized using remote sensing satellites. So when it comes to scientific related data sets, we have DMSat. DMSat is being developed by international partners and also Mohammed bin Rashid Space Center. And it's a project owned by Dubai municipality. So utilizing the data that comes from DMSat will help us in monitoring and measuring the aerosols in the atmosphere. It also will help us understand the greenhouse gases and the effects it's taking toll in not just the UAE, but also around the world. And from that, also, Dubai municipality is going to be utilizing this data for finding solutions to different challenges when it comes to pollution around Dubai. Sorry, it's taking time to go to the next slide. So going back to the 4 pillars, I'm going to be talking now about Mars 2117 strategy. So when it comes to the vision of the program, it's to enable the UAE to contribute to humanity's interplanetary endeavors. And the mission is to establish a long-lasting colony by 2117 with international collaboration. So the end goal is to establish a colony, but the program or the higher purpose of the program is to create a lot of initiatives and programs that would encourage collaboration between UAE and also international partnerships. It's also going to be developing in-house capabilities in terms of technology, demonstration and usage, in terms of building scientific expertise in the UAE when it comes to Mars sciences, different topics of that. So it has a bigger aim. The end goal is to create a colony, but the higher purpose is for education also, to inspire the new generation to go into STEM fields, and also to build UAE to be the active partner when it comes to adding into understanding Mars in general. So one project or initiative that came out of Mars 2117 is the UAE analog mission. And this mission is to, it's a scientific mission by in a station called Ceres. It's located in Moscow, and the analog mission is for an 8-month-long ground-based facility. And the purpose of this mission is to study the effects of isolation on the human body, the confinement in terms of psychological, and also in terms of team dynamics. So there will be lots of members, and how do team work in stressful environments, such as going into the exploration for long duration missions. So it's the first of its kind in terms of, for the UAE, in terms of the scientific fields that we're going to be adding into and learning from. And so far it's in the candidate evaluation phase. Now going into the human spaceflight program. So the human spaceflight program was announced by His Highness Sheikh Mohammed bin Rashid, and from his announcement, it was basically a call for the Emiratis to participate and be the first team of astronauts representing the United Arab Emirates. So the objective from that is to position UAE to be an active participant when it comes to human spaceflight, and also supporting the vision of the UAE when it comes to moving from an oil-based economy into a knowledge-based economy. So sending astronauts to space to carry scientific missions, but the program is not about only selecting the first batch of astronauts and being the first in the mission. The purpose of the program is to establish a sustainable astronaut corps, a team of astronauts that will be adding more candidates every couple of years to participate and do scientific experimentation on the ISS and also on future platforms to be utilized and for conducting these experimentations internationally. Now, the first mission was the UAE Zaid ambition, and as you can see, we have on our right Hazza al-Mansouri, that he was selected to be the prime astronaut in the first mission, and also we have Sultan al-Niyadi being the backup astronaut for the mission. And the purpose of his mission, the mission was launched in September 2019 with a 8 days duration, and Hazza was chosen to do education outreach in the International Space Station, as well as scientific experimentations that would be added to the or alongside with the international partners on the ISS. Now, when it comes to microgravity related missions, so the main objective or the main scientific objective of the bigger umbrella when it comes to going into the ISS and doing studies is to further our knowledge when it comes to supporting future missions. So this is done by conducting research that would be preparing us for human exploration in the future of our solar system beyond low Earth orbit. So from that, we have a couple of scientific areas that is interesting to study when it comes to microgravity related topics. Of course, it's not limited to these. There is a lot of topics that can be ventured when it comes to microgravity sciences, but these are the main ones that is highlighted here. So we have the food security and sustainability. So basically, if a future mission to outer space, it's very important to understand that we have very limited resources when it comes to food. So how are we going to be sustaining the food? For example, utilizing the different parts of the food, even the non-edible ones. So there is a lot of studies that's being done in this area in order to make sure that we have sustainable amount of food when we go to a future mission outer space. When it comes to sustainable source of water. So when it comes to having a sustainable source of water, a clean water for the astronaut, how are we going to be reusing the water and cycling it? So this is also an area of interest. It has a lot of branch underneath, and how to provide a clean amount of water for that. Human life support, how do we keep us humans healthy in that without the effects of microgravity or the effects of the radiation that comes from the solar winds. So it's very important to understand our human body and how it's getting affected with time in, for example, ISS, and then maybe also in future missions. Energy and power management, how are we going to be maintaining the power management on space, advancing material sciences, and also planetary contamination management when it comes to how to protect ourselves from being contaminated by different substances, for example, that are unknown to us, or even contamination when it comes to protecting the planet from us contaminating it. So it's about processes, new processes that needs to be set in place, new projects that needs to be talked under that. So these are the 4 pillars. I'm going to be going and talking about the Emirates Mars mission now. So when it comes to outer space, humans are known to be curious, and we like to know about our environment and habitat. Where are we living in? So it's all started with, for example, the North Pole expedition, learning about the poles and the different environmental constituents that is affecting the human body, and also about Earth more. And we have missions that have been to Mars, the Apollo mission, sending astronauts to study, excuse me, did I say Mars? I mean the moon. And also we have a probe that, this is a good example, which is Voyager, that sent a probe to space to study the different planets, the solar system more. And we also have Hope probe, which is a good example in terms of studying different planets, and Hope probe is going to be studying Mars. So it was announced in, the Emirates Mars mission was announced in 2014. And it was announced with 4 program requirements. We have the program requirement that we need to be on Mars orbit in 2021, so aligned with our 50th anniversary of establishing the United Arab Emirates. So this sets us since 2014 for 6 years. Also to develop our in-house capabilities in terms of having scientists to do studies about Mars, encouraging our science community to focus on basically entering into the Mars sciences and doing scientific research about that. The science of that, that's going to be coming from Hope Probe needs to be unique data sets. And also we're trying to encourage and move into a knowledge-based economy from this project. So when it comes to Mars itself, so why are we going to Mars? And a couple of days ago, His Highness Sheikh Hamdan announced about EMM and why we're going to Mars. And I quote him by saying that Mars is a means to greater aims. So our aim is not merely to build a probe and launch it, but build the foundation for tomorrow. So EMM or Immerse Mars mission has bigger aims in terms of building our capabilities, in terms of building, inspiring the youth to go into the STEM fields and go into the science related fields and engineering as well. It's about building our in-house capabilities and our entities here to focus on developing and not just utilizing or using systems. So it has a lot of purpose behind it. So when it comes to Mars as a planet, billions of years ago, scientists believed that Mars used to be to have a similar environment as Earth. So it used to have a very thick atmosphere. We can see from the surface of Mars that there are features similar to Earth in many ways. So we're trying to understand what was the change that affected Mars, and how did it change from what it used to be to what it is today. And from that, we can also understand Earth more and understand ways in which we can prevent Earth from having the same result. So there is a lot of missions that have been to Mars. So we're not the first to go and study Mars, but how does EMM, how is it unique to these missions? So EMM is going to be adding unique data sets in terms of having different local times, data observation of the atmosphere. So a lot of these missions that have already been to Mars to study the atmosphere only study them in specific local times. So EMM is going to be providing a very holistic view and unique data sets that would help us understand the atmosphere of Mars, and also to add these data sets to complement the different missions that have been already to Mars to study the atmosphere. Now, when it comes to EMM, the scientific aspect of that, we're going to be studying the lower atmosphere in all times of day and season. So we're going to be studying the dust, optical depth, the water vapor, and also when I'm talking about the lower atmosphere, it's from 0 kilometer to 50 kilometer altitude. So, so we're going to be studying the thermal state of that. And this is going to be utilized by our first instrument at the top, which is going to be providing us with infrared data sets using our EMIRS instrument, which is an infrared spectrometer. And then also we're going to be studying the water ice clouds in the lower atmosphere and the ozone as well. This is going to be provided using EXI, which also has near UV bands to give us these data sets. And also EXI is used to capture Mars as a planet, so RGB band related data sets. We're also going to be studying the upper atmosphere of Mars, which is studying the hydrogen and oxygen, which is the building blocks of water and how they're escaping the planet, and also carbon monoxide. And this is going to be studied using our far ultraviolet spectrometer in use. And maybe at this, as you can see on the left, these are the instruments, flight models that are already on Hope Probe currently. So since Hope Probe was launched last week, I thought to add this slide just to showcase the journey from after launch. So after launch, the journey of hope is going to be 7 months until it reach Mars orbit insertion. So it's going to be reaching expectedly February 2021. We have a unique science orbit different from the different missions. And this is to allow us to get the different and unique data sets that is needed to answer our science questions. So our orbit is around 20,000 by 43,000 kilometers. With orbital period of 55 hours. And when in terms of communication, it takes around 13 to 26 minutes to receive a signal from Hope probe. So this is, I think, my last slide, and I'll be happy to answer any question at this point.
Thank you, Mariam. This was great. And I think what was interesting about the presentation is that you always bring up capabilities and developing capabilities. So that's always there, like the purpose of all projects. I have a question. Researchers in space sciences, what do they do? How does their daily life look like?
Yes, so in terms of researchers and scientists, so if we're talking about, for example, a specific mission, we have two teams that work under the science team. We have a group that works as instrument scientists. These teams can be a mix of engineers as well as scientists, with a background of, so if you're a scientist in the instrument science team, you also have to have a technical background in terms of understanding the payload and the instrumentation, and vice versa to the engineer. That person has to have a scientific background. So the purpose or the role of that person is to basically take the data sets that is coming from the satellite and translate it in a way that is readable or utilized as a scientific data set for the scientists to do their research. If you can imagine a mission, so if any satellite mission, the data is being sent as digital data, back to Earth. So the instrument scientists take these digital data, change it or translate it using algorithms or tools in a way that is readable for the scientists to do their science questions and answer them. So this is the role of the instrument scientists. And we also have analysis team, so scientists that take this data set and answer science questions. So it's mostly a team, they work together. This team validates the data and translates it in a way, a different maturity level for the science team to do and answer science questions.
Mariam, what about your experience? How did you become a researcher in space science?
Since the announcement of the mission in 2014, we wanted to, so basically there was the science team also that would require, so we needed to require teams and different individuals from Mohammed bin Rashid Space Center and the UAE Space Agency to be part of. And once we began being part of the science team, we needed to upgrade our knowledge when it comes to space sciences. So talking about me specifically, I didn't have that much background when it comes to space sciences or astronomy in general. I just did have the basic knowledge in terms of the different planets, but not specifically about Mars. So we needed to start a different program, which is the Science Apprenticeship Program. And the purpose of this program, which resulted from EMM, is to basically be up to date when it comes to the science knowledge, but at the same time also contribute to the science in terms of answering the science questions. So the apprenticeship program is basically you are mentored by an expert in the field Mars-related expert, and we work together in terms of doing the necessary research and also, for example, if it's related to instrument science, developing tools that will be necessary to translate the data into different scientific maturity levels.
Mariam, can you tell us more specifically about your role in the Emirates Mars mission?
Yes, so I'm a part of the AMM as an instrument science lead, but also part of the mission in terms of one of the instrumentation science apprenticeship project. So the instrument science lead makes sure that all the deliverables that is needed from all the instruments should be in place. Make sure that the resources are in place in terms of what is needed in order to develop these tools. And also making sure that the scientific data will be ready when it comes in and goes into the processing system. When it comes to the EXI, which is one of the instrument on Hope Probe, it's the multi-band imager, which has a near UV and also RGB bands. My role was to be part of the apprenticeship project. So I had a project and I had a mentor with me to keep me on track when it comes to Mars science, but also to work on an algorithm or tool that would be necessary when the real data comes in from Hope Probe to process it for the science community use.
What about your personal experience in all this? Like, what has been the most exciting experience during your time as a researcher in space in general?
So what's exciting about this project is that, or my experience through it, I've been fortunate to be part of it. And during this experience, what's exciting was that every day you learn something new. So you never know what you're gonna learn tomorrow. And it's exciting that you get to learn about the different teams that work in space missions. So you get to see each person and the different roles and how they play and how critical each person is to ensuring that the mission is successful, to ensuring that everything's on track. So it was exciting to see the dynamic of the team. Also, maybe one experience that I recall is the first year that we were part of the science team. We had to go into an international conference called AGU. And this conference is done every year. And a lot of science experts from not just Mars science, but all sciences join this conference, and they get to present what's up to date at that time. So we had to go there to see, to basically know where the Mars, in terms of Mars science and what's the update in terms of the research. And I remember that the first time we were there, people were looking at us because it was the first time Emirati team is there, and it was unusual for them to see us there. And we had a lot of people approach us to ask us about the Emirates Mars mission and basically to know more about the mission and the team. So it was very exciting but weird at the same time to have people look at you while you enter the conference room. And along that, from that day onward, every year we join the same conference, and now we do have a community that that they already know us, and they come and approach us and ask about the status of the mission. So it's exciting to see how we've been involved from the beginning and how people are excited about the scientific data that's going to come out of Hope Probe. So every year we go even to different conferences about Mars science. A lot of people approach us just to see where the mission is, and they want to know more about the data sets so that they can do a lot of science and how unique it is to their research. So it's exciting.
Yeah, Mariam, I can't imagine like how inspiring it must have been to be part of this these conferences and part of this sector in general, and to put the UAE in the map, on the map, sorry. We have some questions here from the attendees. I'm gonna read from my phone. So one of the questions is, what types of scientific analysis is used to analyze the atmosphere to Mars?
Okay, so when it comes to the Emirates Mars mission, we have 3 scientific questions we would like to answer. So the first question is, we would like to see how the lower atmosphere is changing with time and season. So we're studying the different constituents in the lower atmosphere, as I mentioned, the ozone, the water ice clouds, the dust. So we study this in order to understand how the dynamics of the lower atmosphere is being changed with time. So the second question is that we want to understand the upper atmosphere of Mars and how it's changing with time, and why is, or the escape rate of hydrogen and oxygen from space. And the third question is, we want to link. So we're linking what's happening in the lower atmosphere. For example, let's say there is a dust storm and how it ripples. So the effect is rippling to the upper atmosphere. So we're correlating what's happening below with the effects above and how it's affecting hydrogen and oxygen escape. So basically, these are the main scientific questions that we would like to answer when it comes to the Emirates Mars mission. So a lot of analysis comes underneath that. For example, studying the dust along the different seasons on Mars. This is one thing that can be studied. The water ice clouds, at what location it's being, it has more amounts, and how it changes with seasons. So there's a lot of analysis that can be feeding into these 3 scientific questions.
We have some students here that are interested in participating in research programs. How can they do that? Is that possible?
So we have a couple of initiatives that came out of EMM, and one of them is the research experience for undergraduates. So if you're an undergraduate and you would like to be, you would like to learn more about how research is being done, and basically learn about the process of doing research, and also conducting actual research, there is an REU program, which is the research experience for undergraduates, that we announce every year. The program is that the candidate or the student is paired with a mentor. The mentor can be an expert in space sciences or Mars science. They work together in terms of doing research that is needed in the field. And at the end of that research experience, you get to publish actually your results. So it's good in terms of learning or sharpening your skills in terms of research, in terms of also programming. Programming is very important. And it's also important for the whole science team to analyze the data sets. It's a very exciting program that you can be part of. So please follow Hope Probe accounts so that you are up to date when it comes to announcement. There is also the yearly annual science workshop that we do it's open for students and also for faculty members and people who are any researcher who's interested to know more about Mars science. And we do that every year. It has topics in terms of Mars science, atmosphere, geography as well, geology, sorry, as well. So it's open for anyone to be part of. It gives topics that is up to date in terms of science. We also do workshops. So we do camps for the students So now the case with COVID is a bit different, but I'm hoping that everything will go back to normal in time. And if not, we are going to be going through a remote workshop sessions.
Does that include postgrads, Mariam, or is it just undergrads?
The RU program?
Yeah.
It's only for undergraduates. For postdocs, we do grants program. So we have research grant program that is announced usually every 2 years or a couple of years. And in order to fund research that is needed from the science community. So if you are part of a local university here in the UAE, you can submit to that call with a research proposal, either on a topic related to Mars science or space sciences in general.
Thank you, Mariam. Another question here is the UAE planning for unmanned ground vehicles missions to Mars? And when do you expect this to happen?
Yes, so in terms of new coming missions, so we have a lot of missions that is focusing. So in terms of the Immerse Mars mission, we're currently waiting for the new data sets so that we can start working on analyzing these data sets. And as you can see, announcement happened, and we're looking forward for new projects coming up in order to develop different capabilities in order to inspire the youth to go into the space sciences. So you never know what the next mission is going to be. There is, as you can see from the leaders, there's a lot of support when it comes to space sciences and the different projects. And also when it comes to the benefits the UAE is having from these projects in terms of developing our capabilities.
Mariam, we have an important question here. Can a computer engineer work in the space field? And if yes, what can they do?
Of course, you can. So my background is in computer engineering. And I had to, if I'm part of the science team, I had to build my knowledge capability in terms of Mars sciences. Computer engineer is a field or a major that is very important for any mission and any entity basically, and it's very needed in the different sectors here in the UAE. So if you're a computer engineer and you're interested in space sciences fields, you can work in being part of the instrument science team, for example, doing tools and algorithms to validate the data sets and also do research at the same time. You can also be part of the science and do science research. I mean, because all of these science research needs programming skills as well. You can also be part of the science data center. So we have a team that is working, computer engineering team that is working on basically having and making sure that there is an infrastructure for these data sets. And they're working on having a cloud-based data set for databases for these data sets. So it's there is many areas that you can be involved in if you're a computer engineer.
What about other majors that could work in space?
Yes, so other majors are also something that you can easily be involved in the different subsystems. For example, if we're talking about electrical engineering, we do have someone from the team who's also electrical engineer working on science. So it's all about what you actually, you're interested in doing. You can work in the different subsystems of a spacecraft, for example, in terms of development, and also in terms of science aspect of that. We have also in the team chemical engineering members who are also doing and analyzing data sets. So we started when we were part of the science, and maybe I need to mention this also, we're all from the Mohammed bin Rashid Space Center engineers, and we started basically shifting our interest so that we can go into the science field. So we needed to work hard in terms of building our background when it comes to science and being involved in that. So we're all engineers, and we still welcome engineers part of the program, and we also welcome people who are in the space and sciences field, the basic sciences, environmental science, biology, chemistry, because these this is going to be helpful in terms of analyzing the different data sets that comes out of the different missions. Yeah.
There's a question regarding your presentation when you mentioned the 4 pillars.
Yes.
Are these only 4 pillars, or are there gonna be additional pillars added in the future that you know?
Okay, so far there are 4 pillars. There are more projects. There is one project maybe I didn't add because I didn't have much information about, which is the 813 project. And this was announced by His Highness Sheikh Mohammed bin Rashid about having this project and how it's going to be working with different local and different entities in the Middle East to work on this project, university entities. So this is also ongoing as a project by the UAE Space Agency. I believe that in the future there will be more projects coming up as well under these pillars, and just basically looking forward to it.
We have another question here. When will the data of EMM be published?
Okay, so we are going to be reaching our science orbit in April 2021. And from that day, we are going to be validating and calibrating the data sets. So the first data sets will be published in September 2021.
Great, so around a year from now. Another question also about EMM.
Yes.
Hope mission, will it acquire any gravity and magnetic field data?
No, it won't be acquiring these data sets. We're going to be only focusing on studying the atmospheric constituents using our instrumentations.
Just a second, I'm looking at the questions here.
Yes.
There's the question here, the time chosen for the HOPE probe, as in July, is there something behind it? Because, so Saeed is saying he heard that Mars will be closer to Earth.
Yes, and that is correct.
Behind choosing July as the launch month.
Yes, so every 2 years, the approach of Mars and Earth they come close to each other. And July, or this year, it's the closest approach. So it will be easy to launch when Mars and Earth are the closest at that point. And basically July was our launch window. So I think you noticed that we kept postponing our day of launch because of the weather issues in Japan and Tanegashima. So we had a specific launch window to make sure that we launch in this time in order to stay in our trajectory and reach Mars in the expected time. So alhamdulillah, we did launch in time, and everything is as it should be.
There's another question here. Do you have any collaborations with the National Center for Space in UAE University?
Yes, so currently we do have 2 projects that we are working with NSTC. and it's all feeding into the Emirates Mars mission science objectives. So we provide support and guidance in terms of the project, and it's currently ongoing.
Great. Thank you so much, Mariam, for today's session and for taking in these questions. Do you have a final message for the attendees or for the students that are attending this session?
Yes. So the most important thing I would say through my journey is that I learned through my journey is that you need to have passion. So if you are passionate enough to work in a specific thing, or you think that this is the area for you, and you think that this is something that you want to be part of, or you want to work or have a major in, for example, you need to be passionate about it, and you need to make sure that this is something that you want. So I always encourage students when I see them to do your research, research about what kind of field you want to be in, or what kind of studies you're interested in. So if you do your research, information is available online, and you are sure this is what you want to go and ahead, you can do that. So be passionate, do your research, know what exactly you want. Space science is exciting, but at the same time, it's a big field. So you should be excited so if you, for example, chose something that you want to be or we want to work at, you should be excited about it. And life is too short, so you need to make sure first that you're passionate about it to go ahead.
Yes, thank you so much, Mariam. I mean, being passionate is, I think, the most important thing. We have, thank you, Mariam, first of all, for this session. I enjoyed it very much. I'm sure the attendees did as well. And thank you to the attendees, and thank you for their interaction and for their questions.
Thank you for having me.
Sorry?
Thank you for having me for this session.
Thanks. We have another session for our students and attendees on Wednesday at 12 p.m. with Dr. Saeed Al-Khazraji. He's going to discuss his research journey from sulfur to water. Please join us and please register in the link that has been posted in the chat. Thank you, everyone.